All right, hello everybody. I'm David Blevins, and I'm going to be talking about some improvements that we're attempting to make in Java EE7. And before I get started, I just want to take everybody's picture. Can you guys scoot over there, and can you guys scoot over there, huh? just kidding. I'm not even taking a picture, taking a video. Anyway, so this is sort of an informal talk. The goal of this talk is really not to show you the finished product. I mean, a lot of times when you read specifications, you think, if they had only done it this way, those stupid spec people, Well, this is your kind of opportunity to be a stupid spec person and be involved in giving feedback very early in the standardization process. All right, so this talk is basically in two parts. The first part here is what I've kind of labeled infinite extensibility, and it talks about this API that's been sitting in Java EE for really a long time, getting very little usage, and that's the connector architecture and how it relates to message-driven beans. Few people would actually know it, but message-driven beans are not actually JMS specific. When they were introduced in EJB 2.0, message-driven beans, in fact, were very JMS specific. They could only work with JMS. And then in EJB 2.1, the relationship between the JMS provider and the MDB was decoupled. MDBs actually and inbound connectors were created in EJB 2.1. That was in the connector 1.5 specification. And so what the result was is that you were supposed to be able to consume messages or data from anywhere. And so that's the promise. The promise is infinite extensibility, that you can push communication into your server from anywhere, that you should be able to support any protocol coming into your server, and you should be able to do this yourself. So the big question is, when a specification promises something so lofty, we have to ask ourselves, did it deliver? That's really the big question. And in some regards, yeah, it did, but there were some things that made it unfortunately limited. So it's probably easy just to show it. There's a few things that spoiled the show with connectors and message-driven beans, and never prevented people from actually even knowing that they were allowed to do more. Here, I'm just going to pop up in an actual message-driven bean. So this is an MDB, and really, this whole thing right there, that's the problem. That's part of the problem. So the way the connector architecture works and the relationship with MDBs is that you have this thing called an activation spec, and it's basically a Java bean. It's supposed to have getters and setters on it using standard Java bean syntax. And you, as the MDB developer, need to fill in the data for that activation spec. So essentially what you're doing here is supplying a hash map. It's loosely typed, so it's all strings, and you are always put in a situation where you don't even know what the possible keys are, let alone to know what to fill in for the values. You have to continuously look up documentation. That's one problem with it. I mean, and if you look at this is about the most terrible usage of annotations that anyone could possibly ever imagine. I mean, we took annotations which have the ability to be strongly typed and named and have clear defaults, and then we removed all that and then made basically a hash map syntax for annotations. And it's not even as nice as going name and value. It's property name, property value, and it's really too verbose and too clunky. So that's one problem. The other problem with this is that you can only specify metadata at the class level. So a message-driven bean implements what's called a message listener interface, and we're all only familiar with the JMS one because we don't really get exposed to other types. But here there's only one method, and that's fine. So when we have a hash map that configures this bean, it very clearly relates to this one particular method. But now what if you had 3 or 4 methods? I mean, you would have no way with only class level metadata to configure those 3 or 4 methods unless you did something really goofy like put some sort of prefix in there like method 1 dot destination type equals blah, and maybe method 2, you know, it really starts to run short. You can't actually do anything expressive with this. So for a lot of reasons, message-driven beans didn't really ever take off in terms of going beyond JMS. A couple things really, a couple other things, you know, aside from the crippled configuration, you know, I think that that not having a strong second use case really prevented people from understanding how big that world could get. So when you have JMS as the primary thing that people use to identify what an MDB is and what a connector can do, it doesn't really spark the imagination. You're thinking strongly in terms of asynchronous, and in fact, MDBs are not asynchronous. They have no particular messaging pattern. It's up to the connector to decide if that invocation is going to be asynchronous or synchronous. So if there had been like a strong second use case, maybe something that wasn't asynchronous, then people would have had an idea, oh, this is actually supposed to be much bigger than I thought it was, and then maybe they would have written some MDB connectors, some inbound connectors, and that we might have seen this this potential kind of take off, but it never happened, and so that thing just sort of sat there. The other one is that the specification is so big, it's so complicated, it takes you forever to find the parts to understand really what this thing can do. So just to really get concrete on there, I really favor code over slides as much as possible. So here we're going to take, and I'm going to show you exactly the parts that are involved in creating an inbound connector. It's actually really simple. Yes? All right. Too big? Fine? All right, we'll go back up. All right, that's right. Thank you very much. And if you have any other comments like that, just shout them out. Okay. All right, so this is, yeah, once again. So when you create a connector, an inbound connector, you have to create an activation spec, as I mentioned. It implements activation spec, and in it, you basically have getters and setters. So my example connector here is a telnet connector. So you literally can SSH, you know, telnet into a shell, execute commands, and it's stateful and synchronous, showing you that what you thought was MDB could actually be the exact opposite of what is possible. And this is what's possible today. So this is not even the cool improvements that we'd like to make. This is actually just stuff that you can do now. And the goal of this is to show you how much bigger the world is, essentially to provide that second use case that I mentioned. So for our telnet connector, we've got, oh, this is the tomorrow one. Okay, I'm going to do the today one. Okay, so we have a port and a prompt. Those are the configurable properties. We have getters and setters for them. And then basically you have to implement this validate method. And that allows you, as the connector implementer, to validate the data that the user gave you and see if it's good or bad or what. Then you provide a resource adapter, and it implements the connector resource adapter interface. I've moved all of the telnet code into a separate little module so you don't have to get it confused with the connector parts. So you implement this method called endpoint activation, which is fancy talk for deploy. You implement this method called endpoint deactivation, which is fancy talk for undeploy. And in those two methods, you basically set up the MDB, you make it live. So basically, the container will give you this thing called a message endpoint factory. You call create endpoint, and that essentially instantiates the MDB. Really, really simple. Not very hard at all. You take that, you create your message listener interface. And we had, as you can see, in this one we don't have too many methods in there. We do have more than one method. So we've got a do date, do joke, that kind of thing. You take these three parts and you wrap them up into a resource adapter XML file. So you don't have very many moving parts. And we'll just go ahead and see this run. So this is actually using a Archillion to launch off an embedded server. Increased font. If I can remember how. There we go. Okay, that's somewhat readable. Okay, so we'll telnet to localhost. And we had printed the port on the bottom. Actually, I didn't show you the MDB, so let me show you that before I get off into this other area. Okay, so here's what an actual MDB would look like for our fictitious connector. It actually works, but so it's not really fictitious, I guess. All right, so port, prompt, done in hash map style. We've implemented our methods of our message listener interface. As you can see, we have multiple of them, as I discussed. So this is a very, very simple MDB. There we go. Now we've just logged into our MDB. We say help, we get our list of commands. We can say add 2 plus 3, we get 5 as a response. And to show that it's stateful, you can set a little variable and then, list the variables, conference devox. And then we go ahead and say joke, where do hamburgers go to dance, to a meatball. Boom, kids joke was one of my favorites growing up. I don't know if it translates well. Probably not. Okay, and then we'll go ahead and exit. All right, so that was an MDB that was synchronous and stateful. Very different than the way we're used to thinking with MDBs. That's really cool, and it does highlight on some of the amazing things you can do with MDBs, but a fixed set of methods that you have to implement is really boring. And it's not anything that people would really want to use today. If you do start to develop this inbound connector, you have all these questions that you don't really know how to solve in terms of doing modern style APIs. So just to do a recap, we implement the activation spec class, we supply a message listener interface, and that's the connector side. On the MDB side, you use the message listener interface, you put the data in the activation config, or said more simply in a side-by-side fashion, connector, supply activation spec, MDB, implement the activation config. It's really just two parts, configuration and invocation. So the invocation and configuration are both parts that fundamentally need to change in sort of very subtle ways. So the problem here is that the metadata that flows from the user, which is the activation config, to the connector is just this hash map. Why not let them have the full bean class? Why not let the connector have the entire bean class, and the connector can scrape that bean for annotations, and that can really open up the API metadata so that any modern form of metadata annotations on methods, rather than just annotations on classes, could be used to configure our MDB. Secondly, this message listener interface also kind of spoils the show. In EJB 3.1, we added the no interface view, which basically allows you to have an EJB without an interface. And so and any method that you implement on that EJB that's public can be invoked via the no interface view. So there's no fixed contract in terms of methods. You can have as many methods as you want. Why not add this to the MDB design? So one, we open up the metadata so the bean class itself can be given to the connector, and all the metadata of the annotations can flow into the connector and be used to configure what you want to have happen. And then two, instead of just giving this basically business interface version of the MDB, we give the no interface view. And that allows the connector to invoke any method on there. So let's just show what that would look like. This is actually implemented. I work on a server called Tommy, and we have this implemented there. Here we go. Okay. So we keep our same activation spec class as we had before. We add to it the bean class. So the contract here is that when the activation spec has a property called bean class, the container is supposed to inject the bean class. Then in our validate method, we use the bean class and pull annotations from it and use that to configure the various aspects of what is supposed to happen. And our resource adapter stays exactly the same. We haven't really changed anything. But our MDB looks so much different now. No more hash map on the top. Now we have actual annotations with actual Java types in them. So instead of saying string port and a port value as a string, now we know exactly what we can do with this port. And we can specify our prompt, and our message listener interface is essentially just a marker interface. It doesn't need to have any actual methods declared in it. And we're doing a very JAX-RS style of creating an API and exposing that. So now we have a command annotation, which is part of the connector's supplied API. So effectively, our activation spec now is annotations with clear default values and very documented options. So when we go back to our MDB, we see we have a slightly fewer number of commands in this MDB. If we go to run this, already in use. I already have my other server running. Hold on. Yes, disconnect. Okay. One more time. Okay. So now when we go to our telnet, we see the same thing, and it looks like not much has changed. We have fewer methods now. We can still say set foo equals bar, list foo equals bar. We'll exit. But now we can actually change and add to the contract of our MDB ourselves as the message-driven bean developer. So let's add another method here on the fly. Let's say command. Say hello. Try and localize it right. And I'm not sure I remember how to spell it. Is that correct? Nope. Is that it? Okay, awesome. Google Translator to the rescue. Obviously, I looked that one up in advance. Didn't quite remember it. Okay, so we've added a new method here on the fly, and we'll do some other changes to config just so we can see it. We'll change the port to 2021, and we'll change the prompt to Devox. Maybe we'll even like delete some stuff. All right, we'll go ahead and run this again. And now we're booted up on 2021. So now our prompt is Devox. We have our hello command, and it says, I'm hello world. I don't know if I pronounce that even close to correctly. Google Translator's pronunciation stuff, I didn't try. Anyway, so we've done some very, very, very majorly different things right here that might be very subtle and easy to miss. But we've transferred the metadata about how to configure our MDB from the class to the methods. We've added the ability for you to specify any method that you want, as many methods as you need. The connector can design any kind of API it wants. You could do JAX-RS in this style, and it's really kind of unfortunate when you know, MDBs were added, they were tied to JMS, and then there's enough forethought later on to decouple them and create this inbound connector concept and put JMS behind it. But then when JAX-RS came around, and there was very similar concerns of having to duplicate injection and all this other concepts and services that are really basic for a component, for JAX-RS components, at that time we really could have taken and cleaned up the connector architecture even further so that it could support things like JAX-RS. With this type of change to the connector architecture, we can actually do that. And not only that, but you can add very easily any number of connectors that you want. Let's just imagining things. You could do Thrift or Swift, or if you wanted, make yourself a Jetty connector. If your server uses HTTP via Tomcat and you like Jetty better, make yourself a Jetty connector and then consume HTTP messages through the connector architecture. It's totally legitimate. Stomp, SMTP, email. I mean, when you have a very expressive API capabilities like this, it's just really, really, really tempting to take something like JAX-RS, the style of interface that is, that kind of API where JAX-RS is really pulling data out of headers and sort of pushing it into the bean class. You could do something similar, designing an API for email where you're taking email headers and pulling them out using JAX-RS style annotations and pushing them into beans. Really, really opens up this underused, sort of dead, never quite reach its potential API, and actually makes it something that you would want to use and would be enjoyable to use. These are just protocol examples, but you have the ability to push information into the server. Basically, this opens up the ability to do a push. So you could do cron if you wanted to take and wrap cron so that every time the trigger fires, it just poked an MDB inside the server. You could have system events that when they fired, shot an event into the server and via an inbound connector. If you're in Amazon EC2, if you have different cloud events and monitoring events, you could have those flow into your server via inbound connector. SMS, Jabber, all that kind of stuff could happen with an inbound connector. And the greatest thing about it is it would be usable in any server that's certified. So you could write this connector once, and you wouldn't have to go, oh, we can't use Java EE because we need to do this thrift stuff. And it's not necessary for you to abandon the certified platform because you simply don't have a way to extend it. Well, now you have a way to extend it. This ability has sort of been there, but it's been crippled for such a long time. With this change, you could actually do some really fun things with it. So that's the basics of the first part of this talk. And I really, really encourage everyone to send feedback to the actual expert group mailing list. Specifically for this one, it's the EJB expert group. There's a JIRA ticket for this, and if you like the ability to use this in your applications, I would go ahead and vote on that JIRA right now or very soon. As well, the code that I showed you with the MDB that does Telnet, that Telnet connector, that's in a GitHub project, and you can actually grab that and use that as a template for writing your own connectors. It also has the future version of the connector MDB relationship that allows this expressive annotation, any kind of methods API. That code is there functioning as well. As well, after giving this talk, maybe last week, someone came up and said, "Oh, I've written an inbound connector, and man, it took me months to get through the spec. I really wish that I had some resources that I could have used." So we sat down and we made this little GitHub project. The goal of this GitHub project is just sort of like start collecting information about connectors, because this is an old specification that doesn't get a lot of attention. There aren't a lot of articles about it, so it's very under-documented and under-promoted. So that's just a little GitHub quick start project. There's not much there. If anybody wants commit on it, just send me a note on GitHub and I'll add you, because we're just trying to collect as much information as we possibly can on this topic. There are microphones in the room. Are there any questions about this? You will, yes. It's not based on it, but that works with it. So that's kind of one of the advantages of using this, is that the MDB itself, all EJBs are CDI beans. The reverse is not true, because CDI doesn't have a direct dependency on EJB, but EJB does have a direct dependency on CDI. So you can use @inject, and if we wanted to just show it, we can go ahead and plumb that in. Like, let's let me see. Where's my runner? Do. Right. Well, right. The annotations that you, as the connector implementer, would create and expose in your API to the MDB would not be CDI annotations. That you could use them and try and honor them in some way, but it's basically your API that you create. The MDB implementer, the person who writes the MDB, of course, can use all the features of Java EE, such as @inject, private or protected foo. So if I had a foo object or whatever, stop doing that. Space, there we go. You could get get MDB things injected. You could have producer methods and producer fields. You could consume CDI events. I mean, you have the full features of Java EE, including CDI, in the MDB. So that's really kind of one of the major advantages of writing a connector, is that the thing that consumes the messages is fully integrated with the platform completely. So it gets CDI injection, it gets transactions, it gets security, it gets resources, it gets data sources, persistence, context. You can get entity managers injected into it. It can use all of the Java EE features. It's as powerful or real a component as a servlet, as an EJB. It's on equal playing field with the platform. So you just need to worry about the connector, and then the rest is taken care of you by the platform. It's part of the really great features that this would offer. So like when JAX-RS came out, and it wasn't really integrated with Java EE, it was unclear how you would get the injection working and how you would get these very basic things functioning. With this style, you can create those APIs and then not have to worry about those details. You get them for free.
Do you still really need a marker interface? Would it be nicer to have that in the MDB annotation, message-driven annotation?
Absolutely. What's that? Oh, yeah. So the question was, we still have to have this sort of marker interface. Wouldn't it be much nicer if we could just do something like this and just move that interface to an annotation? The answer is absolutely yes. It's an optional aspect of this proposal. This sort of gets into the logistics of doing changes to specifications in the JCP. There wasn't planned a connector revision. There isn't going to be a connector 1.7 in Java EE7, for example. The current version is 1.6. So we have to try and get as much in there in a maintenance release for the connector architecture as we can. This sort of tweak with allowing the bean class to be in the activation spec and the container supplying a no interface view, those are sort of small textual changes that don't require any actual API class changes. To remove the message listener interface entirely requires a lot deeper tweaking into the connector architecture. So we probably won't be able to get it in this version, but absolutely it's something that we absolutely want to do in the next version, probably even more. Yeah, this is such an critical, important part of Java EE that isn't getting used. And I have a certain philosophy that something that's there that kind of works but isn't really usable for most people is worse than having nothing. Because when there's nothing, then someone will eventually create something. But when something is sitting there kind of taking that spot, no one actively works on it. So really the goal is to kind of reboot this spec and get it going again. Any other questions? Yeah. In terms of externalization, no, that would be very similar to JAX-RS, where it's just in the code. The connector itself could provide some functionality for overriding. Perhaps they could say you could still use the string value pairs in the activation spec, and that would override the annotation data. And those activation spec properties can be configured, of course, in the EJB jar XML via XML. So that would be one potential way to override. But that would be up to the connector to create a way of overriding the annotation data. Anything else? All right, let's move on to the second topic. Yeah. That is one way of I mean that is potentially the way to. Okay, let me repeat the question. The question was, this changes the administration role from the container to the connector. essentially, in some regards, yes, the container is no longer in the business of shoveling metadata to the connector. The connector gets the metadata directly from the MDB developer. So we've cut one part out of, we've cut a middleman out of the equation. It's just the MDB developer and the connector who more or less communicate directly now. So there's as much administrability as the connector wants to put into its API will be there. There could be an external file that's referenced and that would read things out there, and that file could be referenced in annotation or something like that, or system properties, whatever the connector would choose to do. I mean, the great thing about this is that you're supposed to be the connector developer, so as much administrability as you want to build into your APIs is what you have. So whatever your needs are, you should be able to satisfy them. Well, that sounds wonderful. I mean, I would suggest commenting on the JIRA or shooting an email off to the users, to the EJB spec group. We don't get a lot of feedback, surprisingly. We go and say, can we send feedback, and then we don't really hear any. So when I said sort of in the beginning, this is your chance to be a quote-unquote stupid spec developer, I really mean it. I really want people to participate and send feedback, and it sounds like you got some good ideas, and I would love to see them and hear about them. Oh, awesome. Okay, great. Yeah, which spec do you work on? What's that? Okay, awesome. So yeah, please get involved. We need more active people. All right, we're kind of running short, so I'm going to show this second one. The second one is an annotation reuse concept. All right, so independently in maybe like 3 specifications in Java EE6, this annotation reuse concept popped up. And it's in CDI, it's in Bean validation, and it's in JAX-RS, surprisingly enough. So let me just show it to you because it looks better. So let me just show it to you because it looks better to see it. And okay, so I've got a bunch of examples here. And first I'm going to show you, so you can understand the motivation for why annotation reuse is important. Maybe an idea. So increasingly in Java EE, you have what I call annotation bloat. You have a bunch of annotations that really just, they start to stack up, and you have more annotations than actual code in some situations. So here's a little simple EJB that uses the EJB 3.1 schedule expression API. So is this readable? Okay, good. So we have one schedule. This is a farmer bean, and he plants corn in the fall or the spring and harvests it in the fall. So we have an expression that says from late May to early June, plant the corn. From late September to early October, harvest the corn. And of course, if you know any farmer jokes, they have to check on their daughters continuously. So we've got another little schedule that says every minute, check on the daughters, every second of every day. Anyway, so this is a little joke there, but that's because you can't actually unit test something that only happens in spring and fall. You need a little something that you can invoke. So this is great, but there's a problem with this. There's a pretty big problem with this. This is only fine in a trivial use. When you actually have a very sizable application, you have to copy, and you want to do many things in fall and many things in spring. You have to copy this schedule basically a million different places in your code. then you're spraying that information all over your code, and if you want to change those dates at all, you've got to do a find and replace and just hope that you get everything correct. What would be so much better is if you could wrap up and reuse that annotation just like you can have Java object reuse. That is much more readable. That is much more maintainable. Here, planting time is simply what is effectively like a CDI stereotype for this schedule expression. Now this is a prototype that I hacked up that gets around the fact that @schedule cannot be applied to other annotations directly. So this is just sort of a mashup, a workaround for the fact that that annotation does not yet allow it to be applied to other annotations. So it can't be used as a full-on CDI stereotype because its element type is only method. It doesn't allow for annotation type as the target. But the core of this proposal is that we fell short when we added annotation reuse into Java EE. You have the ability to create your own stereotypes in CDI, but all of the Java EE APIs that are there, all the annotations that exist in Java EE, don't allow you to reuse them. You can't wrap up JPA annotations, you can't wrap up EJB annotations, you can't do what I just showed you because it's not allowed. You can create in CDI an annotation that's annotated with @stereotype and load it up with these Java EE API annotations, but the container won't know it, and it's not going to respect them and not going to listen to them. It has no idea what you did because it's not built into the other specs didn't adopt it universally. So the change here for EE7 that we're discussing is to make basically stereotypes universally understood by the entire platform. That's a huge change. So if you had a JPA annotation that was ID and it was @generated, and you put a bean validation annotation not null and above 0, you could reuse that one single annotation that had all those other annotations on it on your JPA beans and get all of the JPA configuration, all of the bean validation configuration, all wrapped up in one annotation that you can use. And here's sort of a extreme case. Here's a little project that shows what an EJB application might look like if you actually started to use all of the many of the annotations that we'd want to get to get the qualities of service. I mean, at this point, this application is more annotation than code. This is a really standard wrapper around an entity manager and just allows you to add, remove, do CRUD operations. And so here we're saying that only the employee and manager can add a movie, the transaction attributes required, and when we do that, we want an interceptor, an add interceptor invoked so we can say maybe do some logic and log that. We're going to do a similar thing. Only managers can delete movies, and then we have a new attribute mandatory, so a transaction must be in progress before this method can be invoked. It will not start one. And then if we have a movie deleted, we're going to use this interceptor and log that. Then we have permissions permit all. Anybody can list movies. and the transaction attribute is support. So you can have a transaction or not. That's pretty verbose. Ideally, you should be able to do something more logical to your code. So we don't even have a persistence unit reference with the unit name in it. We've also wrapped that up. So we don't need to reconfigure all that data every single time that we reference our movie unit. We just simply say @movie_unit. And then we just have an add operation annotation, a delete operation annotation, and a read operation annotation. And if we go to add, for example, we have this setup. Now, for the actual proposal, this would become @stereotype. All these annotations would be changed so that they could be applied to the element type, the annotation type, and what we would have would be this. So that's the actual proposal right there. That all of the Java E annotations that don't currently allow you to place them on an annotation type, we will change them so that they can be placed on an annotation type. And then all of the specifications like JAX-RS, JPA, so on and so forth, will all be updated to say that in an EE platform, annotation inheritance is supported via @stereotype, and you can reuse any of those standard annotations in your application portably. So that sort of brings a commentary about, and here's an example of JAX-RS, how they actually are using meta annotations already. It's little do we know, but @get is actually a meta annotation or a stereotype for HTTP method post. So anytime new methods may be added to HTTP, they put that string into the HTTP method and wrap it up again as another annotation. So like I'm saying, this kind of annotation concept, reuse concept, is starting to prop up in all these specifications, but there's no standard way to do it. Bean validation uses this syntax. There is no @stereotype that drives this. It's all implied. So the bean validation approach to inheriting annotations. So in this situation, the French zip code annotation would inherit not empty, not null, size, constraint, all those things. But there's no annotation that drives it. So in bean validation, it's implicit. In CDI, it's explicit. So @stereotype now says that model inherits named, inherits request scope, and so on. So this is the model that we're potentially going to go with Java E7, and this is sort of where we need some feedback from you to say, what is the best way to implement this for the platform, because whatever we do, we have to live with for 10 or more years. So we have to get it right. We have to get some feedback, because, you know, it's not something we can change once we add it and it gets adopted into all the specifications. There's just a little bit of commentary about the evolution of metadata. And so we originally had XML, and that was where all of our configuration lived. And the problem with this was that eventually, if you wanted things to be configured for individual methods, you had to list the class, you had to list the method name, and then you put the thing that you wanted on that method. And then when you changed your code, like refactored that class and renamed it, of course, all your XML broke because the method names and class names were all different, and the XML wasn't updated. So that became a very big pain in the butt. So people started doing this xDoclet generation thing where they would use JavaDoc on their methods, and it would generate the XML. And then we thought, all right, this is really terrible. In EJB 3.0, we added annotations into EJB, and that got added to the Java language itself. So then all the metadata went from XML into annotations into our source code. So now we have all of our configuration data spread out through all our entire code. And as I mentioned, this becomes a really huge maintenance nightmare, because everywhere you want to do an injection point for your persistence unit, you got to relist a persistence unit name, and if you change that persistence unit name, you've got to do a find replace across your entire code. And all these annotations that have all this concrete information on it, you got to repeat that all over again. So it's very much anti-dry. It's, do not repeat yourself is what dry stands for, and it's very much the antithesis of that. So now, I'm labeling 2009 as sort of the birth of annotation reuse. We're getting a little closer to the ultimate goal. Annotation reuse says, now we have all these annotations that we've duplicated all over the place. We can condense them down into one annotation and use that one annotation. So that's the annotation reuse concept. That came out, like I say, in Java E6 in various specifications. We have not yet gone to the very last part, and here's an example of where I think we kind of need to end up. I'm not sure how long it's going to take us to get here, because even this sort of platform-wide annotation reuse concept is going to be a little bit of work to put in to EE7. But eventually, why not be able to externalize the definition of the meta-annotation completely? I mean, an annotation is just an interface. When you look at the actual bytecode, it's basically an implementation of an interface. So it has getters and setters and things like that, and the data that you put in those fields in the annotation definition essentially get an object created that implements the interface of that annotation. So why not just externalize that, generate that class on the fly? So instead of having at the top here, we have these schedules on planting time. Actually, planting time, the annotation, quote unquote, the annotation won't be defined in code. We define it in XML. So now we've externalized the metadata completely into XML. But our XML, if you notice, does not have any information on where planting time is used. So it doesn't have this class and this method needs planting time in XML. So it doesn't have the big limitation that we had in the very early versions of XML. The big problems with those early versions of XML was that you had to say this class, this method needs this transaction attribute or this security setting or something of that regard. So we had the target information in the XML, and that was really difficult to refactor. The actual configuration data, which was what transaction attribute or what schedule to use, that was useful to have in XML. So as we went through the evolution, what we need to get to is where we have basically these top two. We've got the meta annotation, and we've got the ability to effectively override that meta annotation via a simple XML like this. And I think when we get there, we'll finally reach this perfect level of maintainability and externalizing configuration data in our code without the external information, without the external metadata having any awareness of the structure of our code. So we don't have to say how many beans use planting type. We don't care. We just use it everywhere, and the application could use the @planting type annotation. Meanwhile, the actual configuration of it is externalized, and we can maintain it and tweak it at will. So I'm not really sure how long it will take us to get there, but that's definitely the ultimate goal. Send your feedback to the Java EE Experts group. This is being actively discussed. When we sort of announced that we were backing away from the cloud types of functionality, that was that same day this proposal came to the list and said, let's start talking about this. So this is sort of one of the really big things that we want to do in Java E7, so we definitely need feedback on that. And again, this code is in a project in GitHub called Metatypes, and if you go there, there's a full explanation of kind of the ideas in the proposal and some examples of annotation reuse. Questions on this? We have basically 1 minute left. Yes?
Do you think you have still time to specify those things for E7?
The question is, do we think we still have time to do this for E7? Yeah, absolutely. It's a major initiative for E7. It's most likely going to make it in. We do need some more feedback before that can happen, but absolutely.
Well, the problem is it's not necessarily limited to E7, because at least with Java SE, you may know there's things like type annotations, and they go rogue, and you sometimes have things like you have not null defined by invalidation, and then somebody else defines something as non-null or nullable or non-nullable, so you get this floating to
Right.
exponential level.
Yeah, so my time is up, but yeah, the real statement there is that ultimately this is an SE concern. We did try to get this into Java SE. So far we haven't had any luck with doing that. Ultimately, annotation reuse should be a Java language level feature. So if that is your strong belief, please send that to the expert user list as well, because it's good for that to be heard. But anyway, thank you very much, and I really hope that you enjoyed getting a glimpse of some fun things that are happening for EE7 in the early stage. Definitely send your feedback, and thank you.